Okay, so in this video we're going to take a look at the engineering design process applied to a particular problem. And if you look here in my table of contents in my engineering notebook, I've added in the engineering design process notes from the video on the engineering design process. You can see I pasted in my graphic and then I just summarized the process. So we're just going to run through that real quick because this is what we're going to be applying to a particular problem that I have. So the process is, one, we're going to write out the problem criteria and constraints, and we're going to do that in a design brief. This can be varying levels of official design brief, or you can just go through the process and just clearly describe the problem and list out the criteria. Then we're going to research. We're going to make a list of things that you need to learn. So one of the things with research is, let's say you've got a problem you've got to solve, but you don't know how to do everything. So it'd be good for you to maybe first even just make a list of, well, I need to learn this skill, or I need to learn how to operate this machine, or perhaps use this manufacturing technique to be able to actually produce this product. So make a list of things you need to learn and research that you need to conduct. Brainstorm, throw out ideas in volume and record everything. Select an idea, narrow in on one idea to fully develop. Use sketches to communicate your ideas. Sketches are incredibly helpful for you to be able to think through, is this going to work? Develop a solution. Turn that rough idea into a detailed drawing and a plan. And that detailed drawing should contain enough details for you to be able to build it from that drawing alone. It's going to have dimensions on it. Number 4, build and test a prototype. Develop tests, collect test data, develop a report. Number 5, evaluate your solution. Did it work? What needs to change? And then finally, we're going to present the solution. You can see it goes up there to the top. Clearly communicate the problem, the design, and how the data shows that it actually solved the problem. So I want to apply this to engineering a glue gun holder for my class. So I have purchased, let me swap cameras over here real quick. So I've purchased 7 of these mini hot glue guns, and I want to create a holder that's going to help to organize them for my class. So here is my problem. I have 7 of these mini glue guns, and I want to keep it. I'm writing out, define the problem, and I'm actually writing out what the problem is. I have 7 mini glue guns that I want to keep organized in class. The ends are hot, so I don't want them melting the cords if I put them up into a bin. So I could toss them into a plastic bin, but the tips could melt the bin, melt the cords. Also, they drip glue when they're still hot, so it'd make a mess in the cabinet, or it'd make a mess in the bin, or you get hot glue on the cords. It's going to make a mess. The cords can get tangled whenever you just throw them into a box or a bin, so I don't really want to do that. I need a place to store the glue sticks as well. So I bought 100 glue sticks, and I want a place to be able to store the glue sticks as well. So what are my criteria? My criteria are that the holder needs to hold at least 7 glue guns. I want it to have some way where if the glue gun drips, it's not a big deal. It's going to catch the drips, and then I can peel off or throw all those drips away. But the drips are going to be in a place where I'm okay with it. I want to be able to keep the cords managed. Somehow I want to put the cords up or wrap them or do something to where the glue guns are going to be easy to pull out. And then I want to store the glue sticks with the holder so that everything is self-contained, and I can just grab that out of my cabinet, set it out in the classroom, and students can come grab the hot glue guns. Constraints. Needs to be cheap and easy to build. This is not something I want to spend a ton of time on. I'm willing to spend time on it for this project because of how it teaches us how to use the engineering design process. All right, so I need to research. Does such a thing exist? And here's what I went out and found. Okay, so that looks similar to what I was describing. It's a way to hold the glue gun. It's got a place for it to drip. This is just for a single glue gun though, and it definitely has a place to hold the glue sticks. In the top right hand corner, this is like a horizontal option, so you can lay it flat. It would take up a lot more space in my cabinet, I think, unless I was to stack them, and it doesn't manage the cords, and it doesn't give me a way to store the hot glue sticks. These bottom two are interesting because that one on the left, that is a 3D model, so that means it's 3D printable. So that would be easy to produce, but it's again just for a single one, and I'm not sure that that would nest or stack or anything in my cabinet very well. And the one on the right is a laser cut option, which again, easy to manufacture, easy to produce. If I could just download the files, if I had access to a laser cutter and material already, I could just have the laser cutter run, snap it together, and I'm good to go. So I really want something that's going to hold 7 of them, not just a single one. So now we need to brainstorm. All right, so I don't think I need individual holders. I can build something out of cardboard and hot glue. So I can use cardboard. I've got access to some cardboard. I've got hot glue guns, obviously. So now I think I want to make something out of cardboard and hot glue. So I need to select an idea. So again, the brainstorming could be coming up with designs, but I pretty much narrowed in my mind already how I want to come up with this. So I want maybe like a box that is open on the front and the back with 7 holes in it in the top to hold the guns. So I'll just have like 7 circles cut into the top and then slide the 7 mini hot glue guns down into those holes. And then I want a shelf some distance below where the tips are that can catch all the drips. I'm going to call it a drip shelf. Maybe I want 7 boxes below that, 7 little cubicles where I can just take the cords and shove them into those little boxes. So then you'll have the glue stick with the cord then running down underneath into those boxes. So that'd be an easy way to manage the cords. If I wrap the cords around the hot glue guns, then it's going to be hard to have something where it fits in. So that could be an idea. And then maybe on the side or maybe underneath, I could have a box for the hot glue sticks. If it's underneath and it's a shelf, then I have to make a lip and you have to get them out. So it might be easier to just have a vertical place to set the glue sticks on the right-hand side, for example. So maybe on this side. So how long are the glue sticks? So if I'm gonna move forward with this, so this is a sketch you can see right here of the idea that I have. 7 holes on the top. That off to the right, that little hatch pattern that I drew would be the open area where you can put the glue sticks into that side part. This area here at the bottom, let me turn on my laser pointer. So this area here at the bottom, I probably won't use that. I'll probably just have it be this area right here because I've got the box on the side, so I don't need anything on the bottom for putting glue sticks. So first thing I need to know is how long are the glue sticks, because that might impact how deep it needs to be. So I measured them with my ruler. It's 20 centimeters. Each of the glue sticks is 20 centimeters long. How big of a hole is needed for the glue gun? And the way that I did this is I just took my glue gun and come on, focus camera. And there we go. So took my glue gun and I just measured the diameter there, and I measured this way right here. Sorry that's out of focus. All right, so with that said, I need about a 3.5 centimeter opening, I think. So I'm at the end of my page in my engineering notebook. I pasted in my pictures. So I'm going to continue this on to page 3. If you were to turn the page in your engineering notebook, you might not know that it continues. So it's good to add that continued on page 3. And here you can see I put continued from page number 2. And I added a new title, glue gun holder, continued. And then I'll add this to my table of contents at the end. So how far down will the tip extend through the hole? So I measured to about where I think the cardboard will hit the trigger area of the gun. And with my ruler here, I can see that it looks like it will be somewhere around 7 centimeters, approximately. That's what that little squiggly line means. It means approximately 7 centimeters. So now I'm to the develop a solution part of the process. So a couple of things is how much space do I need between the holes? Do you see, as I think of a question, I'm writing it out. Now I've got this documented so that whenever I come back, I'm not wondering, well, what if I change the size of I can remember why I made them 2 centimeters because I've thought about it, how much space needs to be between the holes. So let's say about 2 centimeters. And the way I decided that is I just looked at my ruler and I thought, you know what, 2 centimeters looks like enough where the cardboard will have strength to continue to hold everything. So let's go with that. So now I'm going to do my 2-scale technical drawing. So I'm going to make each of these, I'm going to pretend like each of these boxes on my graph paper is 2 centimeters. So if I do that, then I can draw this to scale. So I drew a circle here that looks like it's about 3.5 centimeters. So it's just a smidge less than 2 boxes in width, which would be 4. So that's about 3.5 centimeters. And I've got 1 box basically between each of the holes, which remember 1 box is 2 centimeters. So that gives me my 3.5 centimeter hole and my 2 centimeter spacing. And I laid it out. So I want this is a top view, so this is looking down on it from the ceiling. And you can see the 7 holes. And I want it to be about 10 centimeters in depth. I want the box to hold the glue sticks to be about 6 centimeters. And I just took my bundle of glue sticks and measured to see approximately how big I thought that would need to be to hold all 100 glue sticks. And that gives me a total length of about 46.5 centimeters. I took 3.5 times 7 and then added in, 1, 2, 3, 4, 5, 6 spaces plus 2 more. So 6 times 2 is 12 plus 2 more is 16. So 16 plus 3.5 times 7 gave me 40.5 centimeters plus 6 centimeters gives me a total length of 46.5 centimeters. Now, a front view, so looking at it from the front, so the glue guns would stick down like this. So I've got my shelf. I went about 9 centimeters because I wanted there to be plenty of space. I don't want the hot glue gun tip to actually be able to stick to the shelf because that would not be good. And then I bundled up the cords and figured out that maybe about 4 centimeters in thickness would be enough for the cords to fit in. And this one on the end is going to be 6.5 centimeters, and this one, every other one in the middle will be 5.5 centimeters, and then this one will be 6.5 because I've got a full 2 plus 3.5 plus another 1, which is 6.5, and then here I've just got 1 centimeter, 3.5, and 1. So that's 1 and 1 is 2, 2 plus 3.5 is 5.5 centimeters. Okay, so I've got my plan. Now I'm going to move on to building and testing the prototype. So where I am right now is I want to cut maybe 1 3.5 centimeter hole in some cardboard to test out how it's going to fit. So that's what I did here. I took my circle and I cut out a 3.5 centimeter circle. I just drew a square that was 3.5 by 3.5, and then drew a circle, freehanded a circle as best as I could. And now I test my fit for this right here, and I don't like how that wobbles. I don't think that's very good. So I thought to myself, well, maybe 3.5 is just too big and maybe a circle isn't best, because if you look at that, that's not circular. So instead I said, okay, well, let me test a 3 centimeter square. So let's see how that is. And I put it in there and it still wobbles a lot side to side. And I don't really like that. The 3 centimeter square is better, but I just don't like how that fits. So then I measured it exactly, and it's exactly 2.5 centimeters wide. So I did my third one, which was a 2.5 centimeter wide by 3 centimeter tall rectangle. And that holds it perfectly straight, no wobble. I like that design right there. So now I'm at a point where my technical drawing is wrong. And remember, with the engineering design process, we're constantly generating concepts, developing a solution, constructing and testing a prototype. So I basically just prototyped the hole. And now that I see that, you know what, my plan for the hole was not going to work, I need to go back to my developing a solution portion, and I need to update my technical drawing. And remember, we did this in pen, and that's okay. So I can just mark through the numbers. I'm going to write in another color of ink, and then fix this technical drawing, and then continue on with the process. So I'm going to take a break here in the video. I'll cut back once I've done that. Okay, so I have made my changes. You can see I kept the spacing between the holes at 2 centimeters. The thickness here stays the same at 10. Everything's the same for the glue sticks. Each of these are 2.5 centimeters now, and it's not going to be a circle. It's actually going to be a rectangle. So let me draw in the fact that it's going to be a rectangle. There we go. And you get the idea. So we're going to have rectangles. That changes the dimensions to be 33.5. The total overall is still 33.5 plus 6, so 39.5. Means that this one's 5.5, that one's 4.5, and also whenever I placed it in here, I measured this distance here, and it's really only like 6 centimeters. So I feel like 8 centimeters gives me plenty of clearance, so I reduced that from 9 to 8. And now what I want to do is I want to develop a cut list. So you can look at this drawing, but how do I go from looking at this drawing to knowing exactly what I need to cut out? So I need to cut out 2 33.5 by 10 pieces. So one of those is going to be for the top right here, and the other one is going to be for that shelf, because this is 30. Let me switch over to my laser pointer here. So this is 10, so this is going to be 33.5 by 10, and then this one right here is also 10 thick, so it's going to be 33.5 by 10. So I need one piece for here and one piece for here. So those are the two. Then I need one that's 39.5 by 10, and that's for the base right here. So that's this piece right here. Then I need two that are 6 by 12. So the height here is 12. This thickness is 6. So it's going to be 6 by 12. That's going to be for this piece right here, and this piece right here. Then I need two that are 10 by 12, and that's going to be for the ends. So it's 10 by 12 tall. So for those two ends. And then 4 by 10. So this is 4 centimeters tall by 10 deep, and I need 6 of those. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 of those. Now this is going to be open in the back, so the cords may fall out the back. If they do, I can always just cut out a 33.5 by 4 piece and close off the back of those cable holes. But I'm going to try it like this. I'm going to test my prototype. If it works well, I'll leave it like that. If it doesn't, I'll modify it to put a back on the back of those cord cubbies. All right, so now I'm going to start by cutting everything out. I'll glue it all up and then we'll test it out. Okay, so I have completed the assembly. I discovered a few mistakes along the way, which is pretty common for prototyping. Usually you don't get everything right the first time. First mistake, or first thing I didn't consider, is I'm using pretty thick cardboard, so actually the thickness of the material. So what I had to do is these 6 centimeter wide pieces, I had to cut off the thickness of both sides here, so they're actually narrower. So all of my glue sticks don't fit, so if I was going to edit my design for my final design, I would change it so that I make it the whole thing a little bit longer, and that can be a full 6. So I would account for the length, for the thickness of this, and this in my design. Everything else turned out fairly well. What other things did I change? I discovered that on the back here, that this length unsupported was just not going to be strong enough. So instead of cutting a piece of cardboard to close all the way across the back, I just attached these two pieces here so that now that's strong. Everything else basically worked according to the plan that I had drawn up, without really any other surprises, I don't think. So I like the design. If I was going to make another one, I would make it so that this is a little bit wider, but other than that, I think that it turned out exactly how I wanted. Could potentially put some kind of paper or tape down here on the cardboard so it's easier to peel off the glue, or take the paper away and throw that away and then put down a new piece of paper for the next time. Oh, I remember one other thing that I forgot. So looking here real quick at my design, I completely forgot on my cut list to include this piece right here. So I had put 3 10 by 12s. There was one here and one here, but I forgot about this one right here. So that was a mistake here with my cut list. I will come in and edit that to say 3. I don't have my tablet with me right now, so I'll edit that to say 3. But other than that, everything turned out pretty well. And hopefully this was helpful for showing you with a real project, a fairly simple one, how to apply the engineering design process the whole way through. What I would do now is I would fix the mistakes with my design and actually put together a presentation so that I could present that to the stakeholders who are interested in assigning me this work and are going to fund the manufacturing of the project. Hopefully that's helpful.